Okay, so here we go, guys. So let's go ahead. This is the Units 3 and 4 review. This is going to be for all the chemistry at Pierce High School, whether you're in Mr. Fields, Mr. Fortin's class, or any of the other chemistry teachers. So let's go ahead and let's get this review started. I'm not going to go over everything. It's going to be broken up most likely into 2 or 3 videos, so make sure you look at those. I formed them into a playlist, so whenever you click on one, you click on all of them. All right, so let's get that started. Inside of here, what we have going on is this kind of a worksheet. Now, you did this before a while ago, so let's just refresh ourselves. So for figuring out the elements names, you're going to look at the atomic number. And then what you're going to do is you find this thing right here, and that's going to tell you which element you're looking at. So if I have 3, which element on the periodic table has an atomic number of 3? Lithium, very good. So lithium. All right. So that's how you fill out those columns. Now the atomic number, the number of protons, and the number of electrons are always going to remain the same, okay? Unless you have an ion, and that's another story. But those 3 columns should remain the same. The mass number, anybody remember how to find the mass number? Protons plus neutrons, very good. And to find the number of neutrons, what do? Mass minus the atomic number, number of protons, anything like that. All right, so that's about all I want to say about that. Oh, right, one more thing. Sorry. Oxidation number, okay? So remember that an oxidation number is those little columns that's on top of the periodic table. So if you're in group 1, all right, group 1 has how many, or what's its oxidation number? Let me put it that way. Plus 1. How many valence electrons does it have? 1 valence electron. Group 2, what's its charge? Plus 2. How many valence electrons?
2.
Group 13. How many valence electrons does it have? It's plus 3, and how many? 3 valence electrons. All right. So group 14 is plus or minus 4 valence electrons. Group 15, what kind of a charge does it have? Minus 3. It has 5 valence electrons. All right, so the trend continues. And then we got minus 1. Well, that's for 16. For group 17, that's 7. And then 18 has no oxidation number, and it has 8 valence electrons. So it undergoes no chemical reactions. All right, so for down here, discoverers of the periodic table, or stuff about it. Discoverers of the electron was who? Rutherford? All right, so discoverers of the electron, that would be Thomson. They can be used more than once. Okay? Who said that electrons orbit the nucleus like planets? Starts with the B. Bohr, very good. Gold foil experiment was conducted by who? Rutherford. Discovered the neutron. Starts with a C. Chadwick. All right, was the first scientist to state atomic theory of matter? Dalton, very good. Discovered the nucleus? Rutherford. Rutherford discovered the nucleus. Now, who came up with the plum pudding model? Thomson. Yep. All right, so as a reminder, because we're going to look at the next question, as a reminder, the plum pudding model was basically you had a lot of pluses and you had a lot of minuses inside of a nucleus. Now, this was Thomson's idea. So he said that it was just pluses and minuses. They were evenly spread out throughout the nucleus, and that it was a dense, or that they were evenly spread out throughout an atom of something. It was a dense space. Nothing could really go through there. Rutherford kind of changed all that. So if we look at this next part right here, now we're going to either answer proton, neutron, electron, or some combination thereof. So which one of the 3 subatomic particles has a very small mass? Electron, very good. Which 2 have a large mass? Proton and neutron. Which 2 are found in the nucleus? Proton, neutron. Which one has no charge? Negative charge. Electron and a positive charge. Proton. Okay? Let's see. That's all I want to do about that one. All right, now this guy down here, for this kind of a problem, what you're going to do, you're going to count up the number of electrons that you're given or the number of protons that you're given, depending on which one it has. So if we have 1, 2, 3, 4, 5, 6, I look at my periodic table, I find the number that has 6 electrons, or the atomic number of 6, which is what? Carbon. Very good. Okay. Rutherford's gold foil experiment. Sorry about that. Rutherford's experiment. Basically, what he did was he had a particle detector. And he had a piece of gold foil that was in the middle of it, right there. He shot in alpha particles, which are just nucleus of a helium atom with no electrons, and he shot it into the gold foil. What came out was some of them passed straight through, some of them bounced off to the side. Now remember, the current thinking at this time was that Thomson's plum pudding model was the truth, where you had pluses and minuses randomly scattered out, and that the nucleus, the atom was just a dense field of plus and minus charges. Rutherford came along, shot an alpha particle through there, and because some of them went through, what they concluded was that you had a densely packed nucleus in the middle, and then the rest of it was surrounded by empty space. So instead of being like this, what you end up having is this is a positive charge, and then all around the outside is negative charge, but it's a lot of empty space. Okay? So that was Rutherford's gold foil experiment. All right. Cations and anions. Cations are what? Positive or negative? Positive. So remember, cat plus ions, and then anions, a negative ion, whatever you want to use to remember that. So with this one, you're going to write the element symbol and the oxidation number / charge. Okay? So calcium, the symbol for calcium is what? Ca. All right, and then what's the charge on calcium? +2. So you can either write it as Ca2 plus or Ca +2. You cannot write it like this, where you put the charge out front. That's not cool. These two, cool. That one, not cool. All right, iodine. What's the symbol for iodine? I. And then what's the charge on iodine? -1. All right, or you can write it iodine 1 minus, but not that. Okay, the charge always goes to the right. Why? That's just how everybody does it. All right, and then sodium, the symbol is Na. What's the charge on sodium? What's the oxidation number of it? +1. So again, follows the same convention. If I'm going too fast, go ahead and pause the video, and then you can finish watching the rest of it. All right, so for this one right here, you need to refer back to your notes. Those are available on Edline, or you should have them at home. If not, you can go and do a Google search. If you're on YouTube, that means that you can have access to Google. You need to find out which ones are the halogens, noble gases, alkali, alkaline groups too. Give me the valence electrons, which I already gave you. So again, this is group 1, group 2. Skip the D blocks, skip the transition metals. They're not really that important for us right now. There's a lot of crazy stuff that goes on in there. All right, I'm going to pause this and make a new video, and I'll see you on the next one.